In this video, let us continue our discussion on the Graphpad Prism number 8, version 8. How to use this software for prospective studies, including randomized controlled trial, etc. That is for summarizing these prospective studies. The three measures are attributable risk or absolute risk, then risk ratio, and number needed to treat, NTT. For retrospective studies, there is something like case control studies and so on. The best option to summarize the result is by odds ratio. For diagnostic tests, sensitivity and specificity needs to be calculated, and that's the best way to summarize the result. And for correlation, chi-square test for independence, as we have seen that in M18, Fisher's exact test. And for model fitting or regression, we can use chi-square test of goodness of fit and binomial test. All of these are the test for categorical data or the numerical variables. There is nothing but the nominal scale of measurement. So we can use all this in effortlessly in Graphpad Prism. So we'll see that one by one. So let us go to the Graphpad Prism software. On the left side, we can see on example file. The first one is chi-square test of independence. It's the same data that we have discussed in the module. So we now have got three outcomes: high, middle, and low. This is nothing but happiness level. While on the rows are rich, middle, and poor, this is nothing but income. So the aim of this test is that is income level and happiness level are correlated or not. So remember, the correlation does not mean causation. So the whatever the result that we are going to get, the p-value, low p-value, that is significant result, doesn't mean that happiness level is causing effect on the uh, this income level or vice versa. So to perform it, let us do the chi-square test. Analyze and contingency table analysis of the chi-square and Fisher's test, that we go with that option. And then main calculation, just you go with the chi-square test in this case. So let us also inspect the options for 95% confidence interval output. So let us click on our first one. So in the chi-square, usually there is no 95% CI, so that option makes no sense. So this is the data of the chi-square. So the test, the chi-square degree of freedom, the chi-square is 170, which is very high, and degree of freedom is 4. The p-value is very low, so it is extremely significant. The data is statistically significant. So this is how to interpret the chi-square test. So let us go to the next one is prospective study. So in the case of chi-square as well, the table format is contingency table. This is not XY or multiple variables that we have seen that in earlier, not even column. So we go with the multiple, we go with the option called contingency table or two-way table, right? So the two-way contingency is different, but here it is basically the contingency table. We have got three columns and three rows for the usual chi-square test of independence. See, this is the two kinds of chi-square test. So this is a correlation test. So that is called chi-square test of independence or Pearson's chi-square test. Now let us see a prospective study, aspirin and myocardial infarction. That is nothing but a heart attack. So outcome for myocardial infarction this is no MI, while placebo and aspirin treated. So this is how the two-way contingency table is. So for the two-way contingency table with exactly two column, that is two outcome, and then two treatment, that is two rows. So the best option is to go with exact test. So let us click on analyze chi-square test. I click on chi-square test, and we are choosing the Fisher's exact test for this case. And as you see, this one is a prospective study, and for prospective study like randomized controlled trial, all these make sense. Relative risk, let's calculate difference between the proportion, that is attributable risk, and NNT, that is number needed to treat. And these two options we can calculate for prospective result. For odds ratio is usually used for the retrospective, so it is not pertinent here. So these two are important. in the case of the prospective. So we click OK. So as you can see that the table p-value is very low, so that means extremely significant, the two side p-value. Now it's also important to check the effect size. The relative risk is 1.818 with the confidence interval all are positive, so there is definitely a correlation between the two variables. The reciprocal of the relative risk is 0.5501 and attributable risk is quite low, and NNT is 129. So this means that you would expect to prevent the myocardial infarction in one in around 130 patients that you treat. So it depends on should I go with aspirin treatment or not. It depends on the price of the cost of the aspirin, which is very low. So cost benefit analysis is important to interpret the NNT. So this is what the data analyzed, and percentage value is also there. So the risk is extremely important, the p-value is important. So that is how to interpret the contingency table of the prospective thing. Now let us go to the retrospective. In this case it is smoking and cancer. So for retrospective studies, relative risk, number needed to treat, or NNT, it is not NTT but is NNT, number needed to treat, etc., meaningless because the controls are far higher than the number, so only odds ratio should be used. So for this, let us go to analyze, and chi-square and Fisher's test is fine. So in this case we will go with odds ratio for, because it's a retrospective case control study, we go with the Fisher's exact test because it is two-way, two column and two rows. So we go with this option to calculate p-value. As you see, the p-value is very low, so it is highly significant. And odds ratio, you can see the odds ratio is 2.974 and the entire confidence interval is positive, so there is definitely a correlation between the two factors. And other details are also given here. So the Fisher's test and the effect size are very important. Reciprocal of the odds ratio is also important, that we have explained that in the module. So this is for the retrospective. And now coming to the Fisher's exact test for another one. This one is basically NSAID user and non-NSAID user, GBM present and absent. This we have already seen that in the module. So to analyze with the Fisher's exact test, so click chi-square and the Fisher's exact test. So this is basically a prospective. You can also calculate the relative risk and NNT and attribute risk as well. So we'll go with the usual Fisher's test alone to see is there any significance or not. So you can see that the p-value is quite borderline, but still it's significant. So it is p-value summary is just 1 star. So that is how to do a Fisher's test in Graphpad Prism. Now let us see the goodness of fit. So here you see this classical the table, the summary of the Mendel's the dihybrid cross. So as you see, the table format is parts of whole. I explained to you for such data like the pie diagram, the parts of whole is a good option. So in this case, the result can be summarized by a pie diagram of observed versus expected. So now to perform this pie chart, so all you have to go is that to new graph of existing data, and then it will be providing the pie. So we'll go with the pie and click OK to see how the pie diagram looks like. You can see that mostly it is it is basically a round yellow, then comes the two things are quite same. The lowest one is wrinkled green, this one. So this is the pie chart. So now let us go back to the same thing for the chi-square goodness of fit, the same data set. Here to perform the chi-square data set, we will have to click here, analyze, and compare observed distribution. So this belongs to parts of whole analysis. So we have this option, compare observed distribution with the expected distribution. So this is the fit of the two, the model with the data. So that is what observed with the expected. So it is something like a regression analysis. So don't confuse with the chi-square test of independence with goodness of fit. So for goodness of fit, you have to go with this option. And I click OK. Options comes here, actual numbers of the events, which is not in percentage. These are the empirical frequency, so it is actual numbers. and with two rows perform chi-square test of goodness of fit. Now, what are these expected? So in Prism, you will have to manually input the expected frequency. So here you see these are the observed, while expected is all these. So you will have to retype it. 312.75 is expected. In this case, round grain 101, expected is 104.25. I copy it and I paste it in the next as well. And for the wrinkle grain, it is 34.74. In one way, manually entering this is very good, so that you won't get mistaken for the expected and observed. Now I click here OK. The chi-square test of goodness of fit is what I'm going to test here, and the result comes that the chi-square value is quite low and the p-value is very high, so that means that it is not significant. Remember, in the chi-square test of significance, the non-significance is a good option. It means that the model and data is not significantly differing. So there is not much of discrepancy between the models. So the model that we choose is really good, or it is fitting very good with the data in question. So this is how to interpret, the chi-square goodness of fit result. Now let us go with the next one is called binomial test. So in this case, it is basically like coin toss or male or female in the case of birth. So we can go with the binomial test that gives you exact data. So let us do a binomial test. This is also a goodness of fit. Compare observed distribution with expected. I click OK. So instead of going with chi-square test of goodness, we go with binomial test, and male, female, 534 and 466. The expected one is the Fisherian sex ratio, which is 500 and 500. And then I click here OK, so that the result will comes here, the binomial test, and the p-value is basically 0.0366, which is significant, but it is only a borderline significance. So that means that is there any discrepancy, significant discrepancy? Yes. So there is a significant sex bias in the place that this data comes from. So that is how to perform a binomial test. And finally, let us also do a sensitivity and specificity of a new kind of HIV detection test, that test the P24 antigen plus or minus with the outcome is HIV antigen present or no HIV. So this is nothing but the reality, while this is what the test says. So to analyze it, let us go to analysis or analyze, and chi-square and Fisher's test is fine. So let us reanalyze it, and instead of relative odds ratio or NNT attributable risk, we just choose the sensitivity and specificity with Fisher's exact test. So it is absolutely fine to go with this option. And now you see that there is a significance. The results are statistically significant, but more importantly, we have to look at the sensitivity, which is 0.8571. If you remember, in the module we have discussed about sensitivity, that has to do with the deceased persons out of total number of deceased individuals, number of people who are testing negative. So basically sensitivity, quite a high sensitivity means the chance of making the type 2 error or false negative is low. So if the specificity is high, here it's one, that means really good specificity. That means chance of making false positive error is also quite low. So that is what it means. This is having high sensitivity and high specificity of this test. And this is the confidence interval of this sensitivity and specificity. And of course, it is significant. So this two data is a lot more important than the p-value when you're testing for the this contingency table, especially for sensitivity and specificity. So this is in a nutshell how to perform this categorical data analysis in the Graphpad Prism. And remember, most of these things are not supported in the usual Excel. Thanks for watching.